Actually, you will use all the knowledge learned from this chapter in your whole life. You always use all the knowledge learned in this chapter. Let's say first concept we need to learn here is called multiples. I think, do you know what is a multiple? So for multiple, actually, when you have a number, suppose we have number 12. If you can write 12 equals another number, suppose 3 times another number, okay? We can write 12 equals 3 times 4. Then we can say 12 is multiple of 3 and also it's multiple of 4. So definition of multiple is this. Suppose you have two numbers, A and B. If we say A is a multiple of B, that means you can find another number. So suppose if A is multiple of B, that means you can find another number n times B give you A. Okay? This is the definition of multiple of B. A will be the multiple of B. See here, if ask you 12 is multiple of 3, then we find 4 times 3 equals 12. Then we say 12 is multiple of 3, right? Usually here you need to understand the multiple usually always is greater or equal that number. Say, if I try to ask you to find the multiple of 3, all the number less than 3 cannot be multiple of 3. Only 3, that means the smallest number, is multiple of 3. And all other...
1.
Huh?
1.
No, 1 definitely cannot be the multiple of 3. That's
okay,
called
I forgot what it's called.
Yeah.
Then 3 is a prime number.
Yeah, 3 is a prime number, right? Now we talk about the multiple. Multiple of 3, that will be 3 and 6, 9, this kind of number. It's called a multiple of 3. Now, say...
like what you're doing, like 3, and like the factors of 3 is like you're doing factoring.
Yeah, right? That's called the factor. So now let's see example. When you see this example, usually you help you understand a lot. Now let's see this example 3.1. Say both
147 and 357 are multiples of 7. We know that.
Yeah.
Is 147 plus 357 multiple of 7.
They ask you, is this true? Say.
Oh yes, it is.
Why?
Wait, what are we doing?
Here.
If you have two
here.
If you have two same numbers that are multiples of 7, when you combine
yeah. Yeah, you can understand this.
That's true.
Yeah, and you also feel this true.
2, right?
Yes, Rebecca, do you feel is this true?
So.
Yeah.
Yes.
Right.
So.
But to prove this, actually, you can do this way. Say, because we can write 147 equals 7 times 21, right? Say 147 equals 7 times 21. Say this is tell us 147 is multiple of 7.
Then what is 356?
Yeah, we can also do the same thing. 356.
Oh, now I can see. an easier way to do this.
Yeah, this one equals 7 times 51, right?
And then you could just do parentheses 7, parentheses
Right,
21.
right, exactly. Now you add these two numbers. Left side, you get a 147 plus 357, right? Right side, say that's 7 times 21 plus 7 times 51. They have a common factor 7 here, so that means we can take 7 out. You got a 21 plus 51. So say based on definition, A equals B times N. Then say this sum equals 7 times another integer. That means that this sum is multiple of 7, right? Because say this A equals 147 plus 357. Here, this B is 7. This N, that's 72. So we found this sum equals 7 times 72. So that means this sum is also the multiple of 7. Okay? So next time when they ask you proof, you need to do this way. That will be very clearly, logically, right? For the other problem, you also...
It's like the same thing for like 14 plus 6. You can also use a very good logic. Like if you know that like in the past you have 14 plus 6, 16, which both of them are multiples of 2.
Right.
So when you add both of them together, you get 30. And when you now you have to be sure that 30 is a multiple of 2, and it is.
Right. Now let's say B. Say suppose K is a multiple of 7. Then they ask you, must K plus 7 be a multiple of 7?
Obviously, yes.
Yeah,
yes.
This is correct. But to prove this, you can do this. See, since K is multiple of 7, we can write K equals...
But K you could make like K you could make it like K equals
7
8.
times N.
Okay. No, I don't think so. K could be any number, like 8 or 9. Or
yeah, but
when you add something,
but say by this way, if K is a multiple of 7, that means we can find another integer. Suppose that's N times 7 should equals K, right? This is the definition of the multiple. So that means we can write K equals 7 times another integer N. Then we can prog K use 7N plus 7 here. Then we can take the common factor 7 out. We got this one 7 times parentheses N plus 1. So then say based on the definition of the multiple, K plus 7 equals 7 times another integer. Because N is an integer, right? So that means N plus 1, that's another integer. That means K plus 7 is multiple of 7, right? So by this way, we write K plus 7 equals 7 times another integer, N plus 1. So that means K plus 7 is multiple of 7. Now let's see C. Suppose R and S are multiple of 7. Must R plus S be a multiple of 7?
Which one?
C.
Yes. Yeah.
Okay, why? How to prove this?
You can prove it because it's like the same thing as problem A. They're both multiple of the 7, so you know. So I'll write down the formula. I'll write down the formula. No, I will.
Okay.
No, I will.
Yeah, everybody, I separate the screen to the 3 parts. Then everybody write your formula here. Now let's see it. Here.
But I will write it.
Okay, Ali is here, Dago is here, let's see, Rebecca is right here. Everybody write proof. What do you get here?
This is it. Just kidding. My first step's not bad. How is that 7? I'm gonna say from now I'm lagging, so it might take a moment. I think it's R for that one. RS. Wait, is R plus S? What's R plus S? Wait, what's R plus S?
R plus S, we don't know.
Then how are we supposed to get this one? Dot.
Say, actually, you say, you
Oh, I know.
Everybody, you understand, but to prove this one, that's a different story. That's hard.
This one? Yeah, that's what I did, Ellie.
What do you write here?
Oh, R plus S equals 7. No, that doesn't make sense. Yeah, no, it doesn't.
It's not make sense.
Wait.
How you gonna? That's definitely is wrong. You know.
I know. That's why. I know. Let me check my book, see what I wrote. Which one are we on? Problem 3.1?
Yeah, 3.1.
I have finished checking my book.
Yeah, see, now.
Don't. No.
Now, yeah, Ellie, you're right. This one's right.
Why M?
M, that's another integer.
Hey, she's cheating! She's cheating! Because look, the book has the answers! The book has the answer!
Right.
Cheater! That's why I said I checked the books and I had no idea.
Okay, you don't need to say the book. Okay, everybody, listen. What I say, you don't know how to prove. Even you understand this. Let me show you how to prove this. Okay, based on the definition, R and S are multiple of 7. So that means R. You can write R equals 7 times an integer. Suppose that's M. Okay. By this way, say R is a multiple of 7. Then, because they tell you S is also multiple of 7, so that means we can write S equals 7 times another integer, suppose that's N. Then, we add this equation together. Okay, the left side, that will be R plus S. Right side, that will be 7M plus 7N, right? So when we take the 7 common factor 7 out, get 7 times parentheses M plus N. So by the definition, if a number equals 7 times another integer, that means this number is multiple of 7. So based on this definition, R plus S is multiple of 7 because M times M plus N is another integer, right? So then get this way, we proved R plus S is a multiple of 7. Now let's see D. Suppose K is multiple of 7. Is it possible for K plus 23 to be a multiple of 7? Everybody answer this question. Yes or no?
What?
D.
For D?
Yeah. Read this one. If K is multiple of 7, is it possible for K plus 23 to be a multiple of 7?
No.
Why?
Because 23 is not a multiple of 7. Yeah, it's not a multiple of 7.
Right. You know, you can still prove this. Say, suppose K is multiple of 7. So we can write K equals 7 times another integer. Suppose that's M. Then we can get K plus 23 will equal 7M plus 23, right? So we can write this one is 7M plus 21, then plus 2. So we can take 7 as common factor between 7m and 21. So you got m plus 3, parentheses, then plus 2. So this one tell you if you use 7 divided k plus 23, you have a remainder 2. When the number is a multiple of 7, that means when you use 7 divided that number, remainder should be 0, right? Suppose, say, we said 12 is a multiple of 3. So that means when we use 3 divided 12, we got the quotient that's 4, then remainder is 0. This remainder should be 0. Now you use k plus 23 divided by 7, you get a remainder is 2. So that means k plus 23 is not multiple of 7. Okay, because that remainder is not 0. Okay, so now let's go to next example, 3.2. What number between 100 and 200 is both a perfect square and a multiple of 7? Everybody do this.
I have to make a list of the multiples. I mean the perfect squares.
Yeah, you can do that.
This is hard.
And it's a perfect square number, and also it's a multiple of 7.
Wait, 100 is 1? No.
No,
100.
no.
100 is not a multiple.
100 is not a multiple of 7.
I'm just writing the list of the perfect squares first.
Yeah.
I'm thinking of 77. What's 7 times 12 again? No, what's 7 times 13? Can you ask me? Can you tell me what 7 times 13 is?
7 times 13 equals 91.
Yeah, 91 plus 7 would be 91 plus 7 would.
You need Dago, you need to first read this problem
Type it
carefully.
in chat.
Read it. No, don't check answer. Read the problem carefully.
Please type it in chat because I don't want anybody to know my answer.
Yes, yeah. Send me the everybody send me the private chat. Then now let's check who got this one right. Oh, Ellie got it right. Who else?
Now I can the perfect split.
Now let's see. Between what number between this and both a perfect square number and a multiple of 7?
No.
And then it's also 200, I think.
Ellie, wait, I'm sorry. I need to send it to you, even though you already got the answer.
Yeah, I did.
Yeah, Dago also got a correct answer. Very good. So think, if you try to get a perfect square number, perfect square, that means this number should write like a some number square. That number should equal some number square. And also multiple of 7, so that means 7 should be here. Then times another number, suppose times k here. So 7 times k parentheses square. This number should greater than 100, less than 200. So you times this one, that's 49 times k squared. This one should less than 200, greater than 100. So what is k? You can try. When k equals 1, this one's 49. It's not in this range. Then when k equals 2, k squared, that equals 4. 49 times 4, 36, 196, right? Because this one's correct answer. You got a 196. Okay. Now let's go to
3.3.
3.3.
Can I write my answer?
Oh,
Yes, send me the private.
I know it.
Everybody send me the private chat.
Done.
Okay.
Done.
What is the greatest three-digit number that's multiple of 13?
Oh, we're doing 3.3. I thought we were doing 3.4.
We do 3.3.
Oh, okay. Let me resend my answer.
Okay.
I sent you my answer.
Yeah, I got it.
Correct?
I need to check. You need to use, let's see, let me check your answer. It should be, yes, your answer is correct. Very good. Eddie also correct. Rebecca, send me your answer. So,
Answer for 3.4a, correct?
wait. Now let's work on 3.3 first. So to find this one, greatest three-digit number, that's 999, right? You found the multiple of 13, that we need to use 13 divided 999. Now let's see, we can put 7 here. We got the 91, right? Then got the 89. Then we put 6 here. We got 78. 78, you got the remainder, that's 11. So that means if we minus 11 from 999 minus 11 from here, then you get the new number will be divisible by 13. That will be 988. So that means 998. 988 is largest three-digit number that's multiple of 13. Now let's see 3.48. How many integers between 2 and 1004 are multiple of 5? Okay, so now let's see. Eddie, you still use that number as your answer for this problem? 3.48.
Let me recheck that. Since now you're making me really
Scared, right?
Wait, no, that I still use that answer.
Okay,
That's
good.
correct?
Yeah, correct. Dago is also correct. Where's Rebecca? Rebecca, you also need to send me an answer. Now let's see.
Which one are we doing?
We are doing the 3.4a. We are doing this. How many integers between 2 and 1004 are multiple of 5? So to solve this problem, first you need to find what is the smallest number of multiple of 5. That will be 5, right? Between these two numbers, that's first that will be 5. Second one will be 10. Third one will be 15. Then blah blah blah. Last one that will be 1000. Next one will be 1005. Will greater than 1004. So that means you need to stop here. Then you need to count how many numbers here. So because 5 equals 5 times 1. 10 equals 5 times 2. 15 equals 5 times 3. Then blah blah, 1000 equals 5 times 200. So then you say 1, 2, 3, blah blah to 200. So that means here we have 200 numbers. Their difference, that's between any two adjacent number, that's 5. So 5, 10, 15, then you count this way to 1,000. Totally, you have 200 numbers. Now, let's go to B. How many integers between 150 and 300 are multiple of 9?
This is her to last one.
305.
3.4b. This one. How many integers between 150 and 300 are multiple of 9?
Oh, I will send it to someone.
Send to me.
That's probably incorrect.
Now let's check. First one.
Wait, can I write it?
Yeah, now I'm thinking, let me check your answer. This
It's
one.
basically what related to.
What's your answer? There you go.
I send it to you.
You sent it to me. Now you get the different answer with Ali, but it's very close. Now let me check.
Very close?
Yeah, very close. So first, now let's say what is
I got it. I think I got it. Give
wait.
me
Let me find out the first
now.
Yeah. Now you both have the same answer. Now, but I need to make sure you both are right. So first one, that will be, we can do 150 divided by 9, right? Now let's see, 1, we'll put 9 here, that's 6, that's 0. We can put 7 here. 7, that would be 63, right? So that means we need to add 3 to the 150. 153, that's the first number. It's multiple of 9, but greater than 150.
And I'm not too sure, but
This,
it might be one of the answers or the other that I sent you.
this number equals 17 times 9. Okay, this is if we write 153 equals multiple of 17, we write 17 times 9. Then, now let's see what is the largest number of multiple of 9, but it's less than 300 divided by 9. Then we can put 3 here, right? 27. Then remainder is 3. Then put 0. Then get 3 again. This is 27. So we have remainder 3. So that means the largest number less than 300, but still multiple of 9, that's 297. We can write this number equals 33 times 9. Okay? Now you need to count from here to here how many numbers here. Say 17 times 9. Next number will be 18 times 9. Right? Then blah blah, last one, that's 33 times 9. So that means from 17 count to 33, you have how many numbers here? To calculate this, you do 33 minus 17, you get 16, but you need to add 1.
I know, it's 17. I sent it to you again.
Yeah, 17. So, there you go. Actually, you're right at the beginning. You changed your mind. When I said your answer is very close to Ali's answer, you changed your answer.
But you said my answer was pretty close to. You said my answer was pretty close to the answer.
No. I said your answer is pretty close to Ali's answer.
I changed my mind when you were talking. So.
Right. So,
Still get
there you
credit.
go. There you go. The lesson you learn from here should be You need should be confident your answer. You not always not change your answer when somebody said something, right? You need to insist on your answer. Okay, say from this problem, you need to do this way. You got the correct answer, that's 17. Okay, now let's go to next one, 3.5. A. Must every multiple of 15 be, be also multiple of 3? Is this one too? Everybody answer.
Wait, are you doing 3.5? Oh, okay.
Send me your answer in private
Which one?
chat. 3.5a. Must every multiple of 15 is also multiple of 3.
Am I correct?
Wait, what is the problem?
3.5a.
Am I correct?
Yes, Rebecca, you're correct. You're correct. Ellie is also correct. Dago is also correct. Yes. So if you feel it's hard to understand this sentence, you can first set multiple of 15. That's like 30 or 15. Right? 15 is multiple of 15. Then is 15 also multiple of 3? Yes, that's right. So that means this one's right. Now, B. Must every multiple of 3 also be multiple of 15? Is this one too? B. Everybody answer B. Okay, Ellie correct. Who else?
What's the problem?
B. 3.5. B. Okay, Dago is correct. Rebecca? Oh yeah, both, you're all right. So this one, this is wrong. You know why? Suppose 6 is multiple of 3, right? But 6 is less than 15. Definitely 6 is not multiple of 15. So that means this B, that's wrong. Okay, so we finished this section. Now let's go here, see if we have now let's see, let's go next section, divisibility test.
That was so quick.
Yeah, that's so quick. So
Oh,
now
you did the next chapter.
not chapter, it's section 3.2. This one called divisibility tests. You know, the one way to check if a number is a multiple of another number, you can use a division to check the remainder.
Or you can use division rules, like number 3, if you know that is 32 a multiple of 3, you know that, you know why? It's not, because when you add this 2 digit, you get 5, and 5 is not divisible by 3, so that's not a multiple of 3.
Right. So here, the way to check if a number is a multiple of that number, you need to use division. So suppose here, we check 12. If 12 is multiple of 4, we just use 12 divided by 4. Check if the remainder is 0. You just use 12 divided by 4. Then you put the quotient, that's 3. Then you get the remainder is 0. So that means 12 is multiple of 4. Right? You just do a division check test. If you got a remainder is 0, that means that larger number is a multiple of that smaller number. Okay? Then now let's go to this example. Suppose example problem 3.6. in this problem, note that this 121,212 equals 120,000 plus 1,200 plus 12. Yeah, you can write this number equals sum of these three numbers. Say, how can we use this fact to tell that this number is divisible by 3? Yeah, say this number is divisible by 3, right? Because each these three numbers is divisible by 3. Say 12 divided by 3, divisible by 3. 1,200 divisible by 3. 120,000 is also divisible by 3. So we check this one divisible by 3. This one also divisible by 3. This also divisible by 3. By this way, we know the sum of these three numbers also divisible by 3. Right? Because 12 divided by 3, you got 4, then the remainder is 0, right? Now let's see B. How can we quickly tell that this number is not divisible by 3? To do that, you check each digit. Say 3, 6, 3, 6, 3, 7. 3 and 6, these two digits definitely divisible by 3. The only last digit, 7, is not divisible by 3. If this number divisible by 3, all these digits should divisible by 3. Because we already have 3, 6, 3, 6, 3 is divisible by 3. You can imagine when you do this division by 3, you say you put 1 here, put 2 here, put 1 here, put 2 here, put 1 here. Then you have this 7 left. Then you put a 2 here, you got a 6. Then 7 minus 6, you got the remainder is 1. It's not 0, right? So definitely, but you don't need to do that. Then you just check each digit, all these digits except this 7 divisible by 3. So that means this number should not divisible by 3, right? So now let's go to next example, 3.7. So this one, they ask how can we tell at a glance whether or not a number is a multiple of 10. Everybody send me your.
Wait, wait. What do you mean? What do you mean by 3.7?
The 3.7. The problem is 3.7.
Oh, okay.
See here.
How can we tell?
So Dago, can you see my screen?
Yeah.
Yeah. See, we are talking about.
Done.
Yeah, you're right. You're right. If there's a 0 at one digit, right? If a number with 0 as one digit, like this, you check this one digit if it's 0. If the one digit is 0, then this number definitely will be multiple of 10. Otherwise, this number is not multiple of 10. Say 50, 100, they're all one digit equals 0. But like 53, the one digit is 3. So this number is not multiple of 10. Right? Great. Now let's continue. 3.8. Is any multiple of 10 also a multiple of 5? Is this one true? Everybody answer this question.
Yes.
Yes.
Which one?
3.8a, this one.
Yes.
That's obvious.
Yeah, this is obvious. you know, the multiple of 10, that's 10, 20, 30. This kind of number definitely is also divisible by 5. So that means this one's yes. Good. Now let's go to B. How can we tell at a glance whether or not a number is multiple of 5? Send me your answer in private chat.
Wait, which one?
B.
B?
Yeah. How can we tell at a glance whether or not a number is a multiple of 5? How can we tell that?
Now as times 10.
How can we tell a number is multiple of 5? You still
Am I correct?
Yes, you're right. Either end at in 0 or 5. Yeah, Rebecca, you're right. That number either end with 0 or 5 on the ones digit. Then that number will be divisible by 5. Like 25, 30, 35, 40. This kind of number is multiple of 5. Otherwise, they cannot be multiple of 5. Now let's see C. How can we tell at glance whether or not a number is a multiple of 2? Yes, Ellie, you're right. Who else?
Not so obvious.
Yeah, this one is obvious. So Dago and Rebecca.
Your camera looks
Is
so
it number? Is it for B or C?
C. Yeah, this should be even. Yeah, Dago, you're right. Okay, now let's go to 3.9. A. Which of 14 numbers are divisible by 4?
this is wait.
These numbers, these 5 numbers, which all, yeah, Ellie, you're so smart. Yeah, you're right. Who else? Which number are divisible by? Oh, Rebecca,
Am
you're
I
also right.
correct?
Yes, you're right. Rebecca, you're correct. There you go. What's your answer for this one?
You can do with 12.
Yeah, because all this number end with 12. If a number divisible by 4, we just need to check the last 2 digits. These 2 digits. If these 2 digits divisible by 4, then this number will be divisible by 4. Because 12 divisible by 4, therefore all these numbers divisible by 4. Now let's do B. Is every multiple of 100 also a multiple of 4? Is this one correct? Yes, Ellie, you're right. Okay. Rebecca?
100 is something of 4.
Yeah, is every multiple of 100 also a multiple of 4?
Am I correct?
No. You can say multiple of 100, that would be 100, 200, 300. Is this kind of number also multiple of 4? So you need to use 4 divide all these numbers, see if you can get a 0.
Well, 100 is a multiple of 4, so all of 100's multiples has to be a 4.
Yes,
Like,
yes, right.
multiple of 4.
Yeah, because 100 is multiple of 4, right? So then definitely 200, 300 also will be multiple of 4. So this one is true. There you go. How you write this one? No. This one is true. Yes.
It's opposite day.
Okay. Now let's go to C. Use your answer to part B to explain why this one is divisible by 4.
Because oh my god, this is so hard to explain, but it's not. Am I correct?
You need the last 2 digits. Check the last 2 digits, not because the ones digit. You know the ones digit.
I got it.
Yeah, suppose I give you a number 18. This number end up with 8, right? Is 18 divisible by 4?
You don't have to say.
Don't say it yet. I'm not done typing since this is so long to write.
I can't spell divisible, so I'm just gonna do.
Yeah, now, Rebecca, you got it correct.
Me too.
Let's see, there you go. Because 8 is 1 is not divisible. No, there you go. We are
I did a mistake because it's opposite day. I told you it's opposite day.
No, it's not opposite day since you just said that, but then it's opposite day.
It's opposite day, exactly. When you say
Am I
opposite.
correct?
Yeah, let's say yes,
I'm
and
correct.
you're right. So there you go. What did you tell me? That's not right. You know, they ask you this one divisible by 4. You said that one is not divisible by 4.
Exactly. It's opposite day.
This one is divisible by 4.
I know, it's opposite day.
Oh, okay. Opposite. Okay. Then now let's see D. Use your answer to part B to explain why this one is not divisible by 4.
Just because of the 10.
Yeah, you're right. Because the last 2 digits.
Am I right?
Yeah, you're right. Rebecca, you're right.
Not because of the 10. So
yeah, 10 is not divisible by 4. So therefore, this number is not divisible by 4. Now let's go to 3.10. Say this problem asks you first. Now let's write 765 equals 7 times 100 plus 6 times 10 plus 5. Right? Now we write 100 equals 99 plus 1. Then write 10 equals 9 plus 1. Then we distribute this 7 to here, distribute this 6 to here. Then we write this one as 7 times 99 plus 7, right? This one you just distribute this 7 to here, this 7 to here. You got these 2 terms. Now you also distribute 6 here, 6 to here. Then you got a 6 times 9 plus 6, then plus 5. Then you move this term here, you move this one to second, move here. Then see the number you left, that's 7 plus 6 plus 5. See, let's check these terms one by one. This number divisible by 9, right? This number also divisible by 9. But say this one, 7 plus 6, 13. 13 plus 5, you got 18, right? 18 is also divisible by 9. When you use 18 divided by 9, you get 2. So now A, as shown above, this number equals this. Notice that 7 plus 6 plus 5 is divisible by 9. I explain why this tells us 765 is divisible by 9. Right? By this way, because This one divisible by 9. This also divisible by 9. If this one is divisible by 9, then 765 will divisible by 9. If this one is not divisible by 9, that means this whole number will not divisible by 9, right? Now let's see B. Notice that 8 plus 5 plus 1 plus 4 equals 18, right? 8 plus 5, that's 13. 13 plus 5, you got 18. By this way, explain why this number is divisible by 9. Okay. Is everybody can explain why this number divisible by 9?
Which one?
Because it's a
B.
multiple of
Oh,
1.
I know. Because when you add it all up, 8 plus 5 is 13, 13 plus 1 is 14, 14 plus 4 is 18, and then 18 is divisible by 9, so that means it's divisible by 9.
Yeah.
It's too easy.
Literally, it's right, but actually, they ask you explain like this way.
It equals.
Yeah.
You just have to break it down.
Yeah, you need to break it down to like this. Write this one at 8 times 99 plus 999 actually, right?
Plus 1.
Then plus 5 times 99, then plus 1 times 9, then the left, that will be 8 plus 5 plus 1 plus 4. You need to get this. Say, this term is already divisible by 9. This also divisible by 9. This also divisible by 9. Then, if sum of these 4 digits divisible by 9, this number will divisible by 9. Otherwise, this number should not divisible by 9. Then we check this sum equals 18. 18 is divisible by 9. So that means this number is divisible by 9. Okay, that's the reason. Now let's see C. Determine whether or not this number is divisible by 9 without dividing 9 into this number.
Like, can you show our work?
Yes. Everybody do this. Determine if this number is divisible by 9.
Time to do a shortcut, okay. It might take me a while to write this, though.
Oh, okay, that's fine. Let's see.
Yep, it is a multiple of 9.
Why?
Is. Because when you add all the digits up, it's 27, and 27 is divisible.
Yeah, that's what I did.
Right, exactly.
So
yes.
easy.
Add all their digits together, you get 27. 27 divided by 9 equals 3. So that means this number divisible by 9. Okay, good. Rebecca also got a correct answer. Very good. Now let's say 11. Say in the previous problem, we noticed that this one, 765 equals this. Are both 99 and 9 divisible by 3?
Yes.
Yes. So that means this one is yes. Now is 765 divisible by 3? Yes. Because 765, we already know this number divisible by 9, right? Definitely this number will divisible by 3 because 9 is divisible by 3. So is this number divisible by 3?
Yes.
Why?
If you break it down,
everybody do this.
It's pretty easy actually.
Yes, yes. Then go send me your answer. How you do this?
Okay. I'm not gonna say how I did it, but
Send me your private chat.
yeah, I know.
I'm writing some wrong thing. Is it C or D?
C is 67,242 divisible by 3.
Can I say it? Can I say it now?
Yes.
Yes, because when you added them all up, it's equal to 20.
Yeah, that's what I literally just wrote. I mean, equals. I meant to write
Right.
equals instead of minus.
Yes, yeah, Rebecca also
6
correct.
plus 7 plus 2 plus 4 plus 2 equals 21.
Yes, the sum
yes.
equals 21. 21 divided by 3, you get a 7. That's divisible. So that means this number is also divisible by 3. Okay, D. Explain why this number is not divisible by 3 without dividing this one by 3. Okay, how to do this?
Is it? If you break it down again, or if you plus some stuff?
Yeah, plus. You don't need to break it down. Break it down just help you understand. That's one takes time. You don't need to break it down. Just add their digits. If their digits divisible by 3, that means this number divisible by 3. Otherwise, this means this number is not divisible by 3. When you add these 4 digits, what do you get?
But I meant to write 19.
Yeah, you get a 19. 19 is not divisible by 3. When you divide by 3, you get a 6. Remainder, that's 1. So that means this number is not divisible by 3. Then, now let's say 12. This one, if A is a unit digit in the 4-digit number, this one. If this one is divisible by 3 and by 4, then what are all the possible value for A? Everybody do this.
Wait, is there more than one possible value?
I think the answer, you can try it. The answer.
Wait, there's 1 minute left.
Yes.
Am I correct? I meant only to write one thing.
Yeah, that answer is correct.
I wrote down 9, but you didn't get it, I believe.
Okay. So you need to add the digits together, right? Add this one together. Check if this one is
see like what is divisible by
3.
3 and 4. And then
You add this one together, you get this one equals 13 plus 8. So that means if this number divisible by 3, that means A should equals, let's say 2, that's one choice. Another, it's, what else? It's 5 is another choice, right? Then what else? Say for if this number divisible by 4, you get a 13 plus 8 divisible by 4. That means these two numbers, 3a 30 plus 8 should be divisible by 4. So that means a equals 2, and what else? 36. So a also 6 is also 5. Right? That's it. Then the common, because this number should
be this one, it has to be this one.
Right. So the correct answer should be 2. So time's up. We can stop here. Your homework will be all the access problem we left behind each section we already learned. So we can stop here. See you next time. Everybody, bye.